Welcome to Going Serverless with SaaS extensions. My name is Norman, and today we will demonstrate how we can extend software service applications like Oracle's HCM with OCI resources such as Oracle Functions. For the first section, we're going to show and discuss the end-to-end integration architecture of our full SaaS to OCI connectivity. Next, we're going to create inputs for integration to process 2 new employees on HCM. Then we're going to activate our integration, check its status, and finally view the output of our integration object storage. Let's get started. This is a high-level view of our end-to-end architecture. It involves 3 components: a SaaS application, Oracle Integration Cloud, or OIC, and Oracle Functions. Our solution goes from polling for inputs from the SaaS application HCM, requesting and passing the input data from OIC, then processing and handling the data with Oracle Functions. Next, we'll dive into the details of a more detailed view of our solution.
Here we have an integration showing full connectivity between HCM and Oracle Functions. This integration takes a list of new employees from HCM, and with a for loop you can see right here, passing each employee data to Functions for processing. Let's dive into the details. What you are seeing here is a scheduled orchestration integration. This allows us to only retrieve the latest entries from a specific point in time. Here we are getting a list of entries. Then we're counting the number of elements from that list. With a switch statement after, we can either skip the sequence below if the list is empty. Otherwise, we will run what follows. In the sequence, we are iterating through the array. We are making a GET request to HCM for specific employee details, and then mapping and passing the received data to another REST adapter, our POST request to our function. With that said, let's see this in action. We'll demonstrate the integration's flow at runtime.
First, we'll add 2 new employees on HCM for our integration to process its inputs. We'll name these 2 new employees Naman1, Naman2. Now that I've created the employees, we can search these employees in HCM's directory. Given that they have the same first name, we will search for the name Naman. As you can see, we can now find the new employees Naman1 and Naman2. Next, let's jump into OIC and trigger our integration. Under current value, I have the recent time right before I created the new employees, so we expect our integration to take in 2 new employees to process. So we'll just press submit here. Checking the status, we can see that it was successful and that it completed. It also processed 2 new employees as shown by the badge on the for each statement. Let's hop onto our object storage and we'll find 2 new files containing the respective employees' data stored in each file. We'll download these and we will find 2 of our new employees' data, Naman1s, Naman2s. Now we will talk about the function we are connecting to in our integration. For this section, we will go over setup, the breakdown of the function used in our connectivity, deploying it, and then we will talk about why leverage functions at all. Next, we will check if our function did deploy on OCI's console. Then we will show how the REST adapter in Integration Cloud is configured and mapped. Lastly, we will show the schedule component and scheduling. So let's get right into it. But before we start, you should follow this link on how to get started with functions. This is a setup guide for functions development. With that said, let's go see our function. Our function uses the Python SDK and authorizes a request with the use of resource principals and OCI's dynamic groups. Now going to the function, the first method we have here is the handler method. It is the entry point to our function. At the top, we are calling the resource principal constructor to pass later. We are making use of this to securely authorize our function to make API calls to OCI services. In the middle, we are breaking down and consuming the payload passed to the function. Then, we are building the object name and the object content using the information we got from the payload. Next, we are passing everything to the next method, putObject method. In this method, we are instantiating the object storage client to make the request using a method with the same name, putObject. Do note that the OCI namespace here is set as one of the function's configuration. We will set this later. Finally, after making the request and returning the result, our function has accomplished its purpose. Now we are going to prepare to deploy our function. First, we will set the OCI namespace, our configuration variable. Now we can go ahead and deploy our function, and we'll talk about why we're using functions next. While we're waiting, let's explore why we use functions and when to leverage this approach. For one, Oracle functions are language agnostic. We are not restricted to using only integrations JavaScript. Two, Oracle functions are cloud provider managed. This saves time and resources spent on infrastructure administration and upkeep. Functions eliminate the cost of running a server 24/7 when our business needs only require algorithms to be run when it's needed. 3. Oracle functions allow external or non-out-of-the-box libraries to support much more complex business workflows. We could use the external machine learning, statistical, graphing libraries, etc. from different programming languages to support business needs that integrations cannot. This is when we could leverage functions in our solution with integrations. Now that that's over, let's check our function in OCI's function console. Here is our function application. We can also check the configuration we have set earlier, OCI namespace. Now let's jump back into Integration Cloud and briefly explore the REST adapter we're using to connect to our function for a post request. Here we have our resource URI from the invoke endpoint. Going back, we can check that we have it here. We are also making a post request. Below, we have configure a request payload for this endpoint, option enabled. On the request, we have set the format to JSON sample with what information we want to map from our integration set here. Next, we'll show how we are mapping data from our GET request to HCM to this REST adapter that makes the post request to our function. By setting what we have under the REST adapter's inline JSON sample that we saw earlier, we can simply map what we have set as the expected data from the HCM REST adapter to our function. Finally, we'll show you what allows our integration to fetch only what is latest. The schedule orchestration integration provides us the scheduler component. With this, we can set the frequency of when this integration could run. It could be every day, every week, every month, or just on set dates. For our integration, we can set it to every day. This concludes our demonstration. Thank you for your time listening. My name is Norman, and let's go serverless with SaaS extensions.